At this point of the semester, you have completed step 2 of your project. So what are the next steps? This video will describe the requirements for the project and demonstrate how past projects accomplished the requirements and earned high grades. The important thing is to first have a fully functioning system. Once you have done that, then you can consider adding special features. Let's look at the instructions for the project. You've already created your real model with cardinalities for the process you have chosen in your industry. The REA model is for the entire process, but the prototype, which you started in step 2, contains only 2 related business events. You need to identify the business rules and the business risks associated with each event. You'll create your tables, you already have done that in project step 2, and invoke the real-time information risk controls that you will learn in the next lab, and you will complete your prototype. You will have an information process to record the events, a maintenance process for each resource, agent, and location, if you have location, and a reporting process for the documents you create in your system. Specifically, you will have at least one table for each object in the 2 events you are prototyping. Of course, we know that you need an additional table for every many-to-many maximum cardinality relationship. And what we haven't learned yet is that some one-to-many relationships require a linking table as well. In your project step 2, if that is required, I have indicated so on your project step 2. You also need one form for each recording and maintenance process. That means that you need a form for every object in your system. You need a form that records each event. You need a form that records new agents, for example, to add a new customer. You need a form for your resources as well. You need to add inventory items. And for the maintenance part, you also need to be able to edit resources and agents. It's an important internal control that you never edit operating events. You will also have a main menu that is organized by areas of responsibility in your system. The submenus are accessed by that area of responsibility. I will demonstrate that with a completed system. You also need at least 2 reports. One must be a notification that a business event took place. For example, if you have a sale event, an invoice would satisfy this requirement, or a profitability analysis relating to revenues. This requires complex queries. Your second report can be one of your own choosing. You will also populate your database, and importantly, you need to test your database to make sure that it is functioning. A good way to do that is to have someone else test your system for you to find out if there are any problems before you upload it. At the time you complete your project, you will also include documentation of the tables, which we call the data dictionary, an ER diagram, which is simply the screenshot of your relationships window in your database, a computer-drawn REA model for the entire process. This is from step 1, except that it's required to be computer-drawn. Let's look at a completed project for the sales collection process of a restaurant that earned a 100%. You will need a database access password and a main menu organized by area of responsibility. Tamana modeled the Corner Bakery Cafe. Let's look at her relationships. She's prototyping the sale event, which is really the order event, where payment occurs simultaneously. And the second sequential event is the delivery of those ordered items. Notice that she has 2 many-to-many relationships. If we go to the cashier submenu, she has embedded additional passwords. This is an extra feature. And the cashier has only 2 responsibilities: recording sales or adding a new customer. She has an automatically generated sales order number, and her time is the default time of now. She has combo boxes for all of her foreign keys. And I will choose the items that I am ordering. She has a subtotal The sales tax is not a calculated field. It's actually a field that gets populated in her table using the set value function, which we will learn in the special features. And the total invoice is $45.68, and she receives $45.68 in cash. She can also print this invoice and hand it to the customer. She can also add a new customer. The wait staff have only one responsibility, and that is to record the delivery of ordered items. She also uses the set value here, which will be demonstrated in the extra features video coming up. These are only the orders that have not been delivered yet, a strong internal control. This is the order we just placed. It populates the ordered information so the delivery person knows what was ordered. She has sales tax here, I'm not sure why, and shipping costs, but we will ignore those two fields. What was the ordered items? Anaheim Scrambler, 2 of those, and 3 commuter croissants. The manager is not an object in her database, but the manager has responsibilities for this system. The manager has access to the bank accounts. She can add a bank account or edit a bank account, add a cashier or edit a cashier. She has search features. And the same with other agents and resources in the organization. Also, the manager is able to see the various reports, including an EQOH report that she created. Timena received 100% because her system was fully functioning. She added complexity by having 2 events that had many-to-many relationships. The only requirement in the system is 1 many-to-many relationship. Her system is attractive. She has embedded many internal controls that are considered extra over and above what is described in the controls lab. And her second report is a complex query with an outer join. Next, I would like to demonstrate how easy it is to create a simple form, like the form to record a new customer. Notice that there is only the sale form and the main menu. I want to add a form that allows me to add new customers and edit customer information. Create, and here we can use a form wizard. We can choose the table, customer, all the fields, and finish. We now have a form that allows us to add a new customer and edit existing customers. Another way to do it without using the form wizard: create form design. In the property sheet, choose the source, the data tab, record source, table customer, and now add existing fields. Customer ID. In fact, you need to have all of the fields on a form to record customer information. By not using the wizard, you are not saddled with the default design provided by Microsoft Access, a form that is simply the customer information ready for you to add designs. For those of you who've taken on the challenge of the conversion process, you are required to prototype only 1 operating event because that 1 operating event has 2 many-to-many relationships. A good example of the conversion process is included in Learning Module 1. I suggest you review that. Quickly, I will review a very simple conversion process database. The design is one event, the perform event, with two many-to-many relationships. Many employees assemble the airplanes, and many materials are used. The agent is the supervisor who oversees the assembly. The form to record the event is similar to what we learned in the lab, except that instead of one linking table, the event has two linking tables. The form, therefore, has two subforms to incorporate the two linking tables for the one event. Similarly, for the report, like the form, it must incorporate the two linking tables. For those of you who have the conversion process, I am available to help you understand the design of your system. Please contact me by email so that I can help guide you. The system evaluation sheet is already available to you on Blackboard. How I grade the database projects is with a starting point of 80%. If you meet the minimum requirements for the project that include two events, but only one event has a many-to-many relationship, the other event does not, and it's fully functioning, you receive an 80%. For every additional effort that you put into your project, you earn points. For industry relevance, for example, if you're a nonprofit, oftentimes nonprofits have charts that show the goals for a particular campaign and how they have reached that goal. Incorporating charts and having an industry focus produces additional points. Extra complexity include two many-to-many relationships, extra creativity in the appearance of your project, or any additional effort, including the special features, earn extra points. The real model with cardinalities is required, and the controls that you learn in the control lab are required. The same is true with the tables, the documentation of the tables, the forms, the menus, and two reports. If you have any questions regarding the project, please do not hesitate to ask me. This concludes this video.